And she's at Marion right now. And part of her training is to come and observe and maybe do a little teaching along the way. We're going to see how all that shakes out. But anyway, welcome, Ms. Price.
Welcome, Ms. Price. Hi, Ms. Price.
All right, let's see who we're missing, and then let's jump in. Get your notes out. Let's see what we got. We're going to do some group work today. After we check and make sure that everybody is here. Uh-oh, where's...
See, Nathan is out. What, Ian? I'm not.
Nobody's seen him today?
I'm not.
You got him around 3-6.
All right, so in your notes packet, you have a page called How Fast Does a Penny Fall from the Empire State Building? So find the page that's called How Fast Does a Penny Fall? And then we're going to go to the back side of that. We're going to do the back side. Now, we are not doing every single page in the whole packet. You can do some of that on your own if you wish. But we've got to get to some of these stuff here shortly. So here we go. Number one, the quadratic function is shown. All right. Find the average rate of change of f on each of the following intervals. Well, let's divide and conquer a little bit. We all know how to find the average rate of change, right? And we know how to use the correct notation when we do that. So let's have you guys over here, Fred. You do the first two, the -1 to 0 and the 0 to 1. Okay. You guys do the 1 to 2 and 2 to 3. You guys do the 3 to 4 and 4 to 5. And then I'll do the last two. We're going to find the average rate of change. Now we don't have an equation, so we're using the points in our chart. Yeah, go ahead, help each other. You can talk about it. If you're confused, you're doing what I'm doing up here. You're doing each of your intervals. Avery, you guys got it done over there? Yeah. These two would get. Okay, perfect. How about you guys in the middle? You guys, what you got, Alan?
-3, -1. Same big guy. 1 and 3.
Wow. Check it out, folks. Take a look. These are the rates of change now. Can we tell this depth? I mean, I know we got a picture in front of us, but can we tell that's not linear? Because what would happen if it were linear? Those would all be the same. Now, find the rate of change, question B, find the rate of change of the average rates of change. So find the rates of change of these numbers. What do you notice? What's happening? What's the rate of change for all of these?
Just two.
They're going up by 2. So your rate of change for all of these is 2. And on last time we had class, we talked about when the average rates of change are changing by the same amount, it's quadratic. That is a characteristic of a quadratic function. So even if I didn't have the picture in front of me, I would know this is quadratic solely based on what's happening to the rates of change. Beautiful. Is the graph concave up or concave down? Well, again, we got the picture right in front of us. Obviously, it is concave up. But do the rates of change support that? Yes, because what is happening to our average rate of change? It is going up. It is increasing. And when the rate of change increases, our curve is concave up on that interval. So it's concave up on the whole shebang because it's increasing everywhere. All right, number 2. Figure out number 2. Now keep in mind, this is a new function. This is function G. So don't look at your picture because that was function F. We want this to be quadratic. So figure out what the numbers need to be so that it would be quadratic. You can do this. Aubrey, you got them? Oh, you don't? Who's got some ideas for me? Kellen, got an idea?
I do not, I'm lost.
I'm lost. Well, let's pause for a second in case there's somebody else that's lost. Did you notice that these are all going up by 4?
Yeah.
So these would be consecutive equal length intervals, which is exactly what we need to make a conclusion, okay? Now, did you notice that right here, this went up by 7, and this went up by 4? Or, yeah. So what's happening? The change in y's over consecutive equal length intervals, the change seems to be going down by 3. If this is quadratic, won't that pattern continue? So if this was 4, this is going to be 1, which makes this a 36. Yeah, 36. What's this going to be? -2, which is going to make it a 34. this is gonna be a -5, which makes it a 29? And what's happening this way? What will this one be?
14.
10, so this is gonna be a 14. And with any luck, this one should be a 13, and it is? What makes something quadratic? The rate of change is changing by the same amount. In this case, it's changing by -3. What would make this linear? Everything would be changing by the same amount. Here, we're changing by 3 less each time. Got it? Okay. I want you to skip. I don't care for that review much, it's fine, you can do it on your own if you want. But go to the page called Circuit Training. Everybody find it? Okay, now how this works, we'll do these periodically, I love them, they're so fun. We start with the question number 1, the first question there. You're going to answer it, and then you find the question, so let's say the answer is 3, I'm making that up. So then the next problem you do would be the one that has an answer of 3 in it, so that would become problem 2. Do you see what I'm saying? And if the answer to question 2 is 200, then this becomes question 3. And ideally, when you get to the very end, the last answer will be 76. It brings you back to the beginning, you complete the circuit, okay? So I want you to work on this with your partner. If you don't have a partner, find a partner. If you want to work in groups of 4, that's fine too. But let's get going on this.
You weren't wondering. We were lying about the answer.
Huh?
We were lying about the answer. You got a lucky guess. It is the.
Oh, is it really?
Yeah.
Yeah, because I totally didn't have it worked out.
I think
No, so it's
Let's see
like,
if I have it.
so 3, so you go to
I swear.
Oh, you already do that one. What number do you put 2? Yeah.
Wait, inside the parentheses, did you do here or did you?
No, I like added it.
The craziest part is it's gonna take us back to
Oh,
7.
it should.
Would you guys care what this price is going to be?
I don't know. Use the
Like, is it helpful?
Yeah. This is an interval.
Well, yeah, you.
Like this is that's like an interval. It's not really like that. Yeah. Yeah.
That one is not.
But then how do you
Oh, you're just supposed to do like,
yeah, and then it's basically just like
thing where you
finding a
do
normal. How do you know that two?
all the way to the
How
S8,
do you know two is
F6.
It's the same formula as you would do for like a normal slope. Yeah, but like you don't have lots. X is
Don't you just, you find the average, right? You add them together and divide by how many, or how many.
Or you get a rest divide by 2.
Yeah, so it's just finding stuff. Like y2 minus y1 over x2.
So number 3, well, I got one right now. It's average.
No. So, this is question number 2. Because that's the
Did you get a positive or a negative 14?
And then you keep going.
You gotta do y2 minus. Oh yeah, minus. So because of it.
Is the answer will be greater than 6 and 1?
No, it's just saying that
I got 3. Go to question.
No. So your answer's 3. I don't know. So your answer's 3. You're right. 1 right here.
So it's like that change.
You guys go from. You go from this one to this one? Yeah. And then what you get from that? 12? Wait, what?
Yeah.
All the way.
Oh, yeah.
I think this is
First, erase that right too. Because like you just write 1, 2, next one, 3, 1. I don't know why I wrote 1.
Oh, it's like the order you're doing on?
Yeah.
That's not 2. That's
Negative.
Wow, yeah. Thank you.
well, yeah, well,
No, I just asked for the rate of change between
So are we fine with the pattern? This one? Well, this is the same thing as the last chart.
What'd you do for number 3?
Oh. Random other aspect.
I feel like it has something to do with
What do we do?
these two.
Yeah.
You just find the rate of change of that and then plug it in.
So that's just saying.
Yeah, do we do 0 and 2?
What is that? Yeah.
That would give us the average.
So if you think about if we were graph this at x at 0, it's -3, and at 2, it's -3, so it doesn't change. So
So
at 1,
it's a
it's still
flat-
going to be a -3, right?
Does that mean it's a flat?
It's a horizontal line, right? So f of 1 is still going to be -3.
Oh,
We have no reason to believe it would deviate from
Okay.
the geometry.
-3 minus -3.
Oh.
That makes sense.
Yeah, that makes sense.
You can.
Divide by 4 every time?
Yeah, it looks like. Zero, is that -3? Yeah. 1's in between, so it's -3.
So it's multiplying by 1/4?
Change that 1.
right, let's do a quick touch base to make sure that we're all pointing in the right direction. What did you get as an answer to number one? 3. So that bumped you down to, the one that had the answer of 3, and that one had an answer of 12. So that bumps you to the problem that had an answer of 12, and that seems to be where some of us are stuck. Okay? Has anybody figured that out? What did you guys do?
Just the X with that equation, filled in for 0 and 2. And the average rate of change is 0, so it just stays.
Well, that would be okay, except it says it's quadratic. And if it's quadratic, the average rate of change can't stay the same. Now, you're saying, but Mrs. Ford, it is here and here. Yeah, because this is a parabola and those are two sides of the vertex. Okay? So, here's what I did, and of course, we never know what the right way is, but here's how I thought about this. Okay. So, my first thought was, okay, this is quadratic, and if I plug in 0, I gotta get -3. So I immediately thought, okay, x squared minus 3. That would work for that point. But it doesn't work for this one. In fact, guys, when I put 2 in, I have to get that same answer, right? So then I thought, okay, then I need a factor of x minus 2, because here, if I put 0 in, clearly I get -3, and now if I put 2 in, I get -3? Well, I wonder, then I have to check, does it work for the other ones? Okay, so what if I put 4 in? If I put 4 in, do I end up getting 5? And if I put 6 in, do I end up getting 21? And I do. So here is my equation. Some of you were looking at rates of change, and I programmed you to do that. I understand completely, but this is quadratic. So you're not gonna be able, things are gonna change, but they're not gonna change by the same amount. So this is how I thought of it. So then it said find f of 1, so I just put 1 into here. And I believe the correct answer is -4. So I gotta go to the one that's -4. Remember, there are 3 basic ways we can look at a problem. We can look at it from a data table, we can look at it from a picture, and we can look at it from an equation. So I chose to write an equation when I did mine, because I couldn't figure out the data table. Okay, that
I think
was,
what I did was okay, when was the problem that we were on? Let's skip to, we just solved the bottom part and find this.
that's the one that I got stuck on.
I took this number divided by 4 to get that number, and then I took that number divided by 4 to get that number. They're both fractions. That is 8, 3, 6, 3, 4, 316, and then take 316 divided by 3, 4.
I understand what hours, I just don't understand what hours.
1 and 2
between these numbers, 36, 4, 2, 25, the difference between those numbers is still not constant, and it will never be constant because
So we're like pattern wise, we're only looking for addition or subtraction. No, like,
right, right.
So it'd be like 5, 25.
That'd be like 7 minus 5.5.
The rate of change of the rate of change. I forget what that's called.
it's just the rate of change of the rate of change.
I just said rates of change don't change consistently.
That's a piece of
But they do at the same time, or at least the Y's do. But they divide at
It's like divided instead of adding or subtracting by something else.
yeah.
I think it, I think it might be exponential, but like, I'm not sure.
yeah.
It just sounds like it's right.
What'd you guys end up getting for A and B then?
So, since we divided over by 4, 3 divided by 4 would be A, so 3/4.
Yeah.
And
Yeah.
then 3/4 divided
So
by
I
4
have
would be
it.
B, which
I
is
have that.
Yeah.
okay, then you take B divided by A. So 3/16 divided by 3/4.
So what do we end up? Well, 16 times 3 is at 48.
Yeah.
One, 4.
Yeah.
There's another part. Oh, this is it.
But because apparently problem number, question number 3 is -4 instead of -3, we have to.
All right, let's do a quick check to make sure we're heading in the same direction. So when I did this problem on the board, I got -4. So the question that has a -4 as the answer, what answer did you get to that one? Who got an answer to that one? Three halves or 1.5? 3 halves, 1.5. And then you move to the one that has 3 halves. I haven't finished it yet.
Is that the answer to this one she's talking about?
Subtract that 100. To only read 3 hours in max. That's like the maximum.
Oh, we did the same thing.
Solve for H so that can't read more than that.
Yeah, I don't know what else.
So we have to do.
I don't know because
Everybody got different answers.
doesn't it go for the Y's it adds 3 and adds 4? Or no, adds 6. And then adds 3 again. But then our X only goes up by 1 now. So,
Okay, so looking at these numbers, those three numbers will tell you which one you're quadratic.
these first 3 right here.
Yeah.
So do we find the average rate of change for those, or no?
Well, we found the average rate of change of these.
Oh yeah.
Is your average rate of change constant?
No.
Then it's not linear. Which means it's quadratic.
And then once you decide. Is the change from 4 to A maybe 3 and then A to B 1.5? I don't
4 to A
think
is not going to be 3. But it's quadratic, so.
What did we get, Sarah, question number 5? The one that had the answer of 1.5, what did we get? What did we get? 2.5, good. And then what did we get? So that became number 6 then. What did we get to that one? 3.5, good. And then that became number 7. And I haven't finished it yet.
He's in his office. No, I think
This one,
I'm not sure it sounds like a mistake.
I don't mind Andy.
I knew he was telling you
Okay, we got a question about, you already figured it out, you don't have to pay attention, keep working. But in case you had a question about the one, I called it number 4. It was the one with an answer, up here it says answer -4. The answer isn't -4, but it's that box. And we're told that this is linear. Oh no, we're not. We have to figure out if it's linear or quadratic. So we have unequal input intervals. That's a problem. This is a change of 2. This is 4. This is 2. And that's 1 and that's 1. So we are in trouble if it's not quadratic or if it's not linear. So let's see. This is a change of 3. This is a change of 6. And this is a change of 3. So we have a slope or a rate of change on this interval of 3/2. Luckily, a rate of change on this interval of 6/4, which is also 3/2. and that one's 3/2. So linear, quadratic, definitely linear, right? And that means that the rate of change between any 2 points is going to be 3/2. Okay? So that means this rate of change right here, or this denominator, x's, that change is 1, which means the change here has to be 1.5, which means A must be 5.5. And then this is also a 1, so this has to be another 1.5, so B has to be 7. Now again, thank God that was linear, because the unequal input intervals is problematic with everything else that we talked about, but luckily it was linear, so that was fine. All right. Now I lost my place.
I think it's the same question. It's like minus 4, because if you do like 6 times,
It's about you gotta go
X minus 1 was X minus 2.
3/2.
X equals 2, X equals 1.
Yeah, no, that was
The
just.
sum of the solution is 3. This is there.
Five. Wouldn't it?
Plug numbers in, find what equals there. Except 3 is 1. Yeah.
No, it's 1.5, not 15.
Oh, I didn't.
Okay,
It's 3/2.
where are we? Number 5, did we already talk about that? What did we get for the answer to number 5? Yep, 5/2, 2.5, good. And then did you get your number 6 then? What did you get as an answer to 6? 7/2, 3.5. What did you get as an answer to 7? 2? Because you noticed, I hope, that 7 was the same table as one of them I have on the board up there, right? So you already had your equation, you just had to set it equal to 0 and solve it. Good. Okay, and then, where was it? Oh, I haven't finished it.
Did we get, for 7
the answer to 6?
Seven, we got 2. Because Big Al, number 7 has the same chart as this one. So I've already done my equation.
What?
Just set it equal to 0
I
and
think
solve it.
it's
That's how you
2.5
find the zeros.
on.
What's that? Okay, that one's fixed, the answer is 7.
$3.5.
What'd you guys get for?
3.5 is not the same as 7.
Oh, yeah.
Remember you guys on, 5.
That's 15 over 52.
Is it?
Where's that even at?
We got 2.
Did you even have to decide? Because Kay just has that first 3 hours.
Stressful.
Yeah, so it can't be crazy. Then she's read 750 pages.
It's asking us today.
That's what-
She has to read 750 pages. So it's 750 equal to 650, 48. No, that's good.
I think Kay is hours.
What?
Yeah.
What
No,
is K?
no,
What is K as
You
a
can't plug
concept?
in the number.
Where's that from?
I don't,
No, because that's your Y.
When-
That's what she has to read. She's already read 650.
I would assume Kay is 3 hours. So like,
If she could read 7.
Claire was right. I did it. I don't know how I did it. But it was
zero, she's obviously gonna breathe for longer than 0 hours. But no, you went to 3 hours. So I think she went 3 hours.
Wait, but the answer's 2.5.
What the fuck? No, how is the answer? There's no way.
The answer.
Well, in 3 hours, she'll read 770 pages, which is more than the book.
But it's asking you what Kay is.
So it means that.
Alright,
she'll finish this.
my number 8 was this one with H's in it. Is that what you had for your number 8? And I got 6 as my answer. Is that what you got? Beautiful. Alright, I want you to set this aside because I got one more thing I want us to take a look at, and it'll take us 10 minutes to do it. So don't lose that paper. That's a biggie. We want to be able to finish that. We may end up finishing on our own. I don't know. 1.3 is Wednesday. So these problems are kind of forcing you to think about things in a variety of different ways. So, sorry. So now what we're gonna look at is this thing called 4 corners. And it comes back to the idea that we can solve these, or talk about these problems in terms of equations, graphs, charts, or words. So right now, we got 10 minutes to get these 4 done. Let's get them done. These are easier. You shouldn't have a problem doing these. And while you're doing them up there, I'll do them on the board so we can compare answers. You can talk to each other. You can do it by yourself.
it is. So,
Yeah. So it would do it.
No idea.
So -2 is less than equal to 1. So you'd use this. You'd use this one. So is that -8?
what I told you was right.
Yeah.
Yeah, it's -8. Why do they have to make math?
I think those are separate.
Five rows, yeah, and then you got,
Teach me taxes.
Less than or equal to 1, you use that. And if it's greater than 1, you use the bottom equation.
and then 5/3.
That's so dumb. 50% of my paycheck just gone. You have fun. Just a day. Let me know how that goes. I'll give them a bunch of red herrings. They'll never find me. Catch your mind. They got bigger fish to fry. Yeah. What is that?
Three is greater than 1, so you have to use that one, right?
Wait, the y values, they go up by 3, but then once they turn positive,
It is quadratic.
they go up by, yeah. So what'd you do to find that average?
They just ask for the average range.
So you okay. Like f of
Except for the last one.
f of 3 minus f of -2 over -2 or -3 minus.
They were easier, weren't they? Yes, so just copy down what I wrote, you need to go and do this on your own. No, but you just copied it down. Where's your,
I was trying to do it a different way, but that's not.
no, average rate of change, it's gonna be S of 9, or G of 9, sorry, G of 9, minus G of -3, over 9 minus 8. Okay, now you look at our picture, what's G of 9?
Three?
Yep. So it's right there, and then you find G of -3, plug into your formula, that's how you do that problem. Don't be trying to be creative.
Why do you think that?
Okay, this is the second question I've had about this last one. What are we looking for in the last problem? X-intercept. So I want you to stop and think about, this would be an x-intercept, right? What do we know about that point? Y is 0. If you are on the x-axis, your y-coordinate is 0. So if you want an x-intercept, you let y be 0. And that will tell you what your x-intercept is. For that first problem, did everybody recognize that in a piecewise function, you have to pay careful attention to your domain over there? So when they say find f of 3 or something, you gotta make sure you're using the row of the function that has an x value bigger than 3, or that 3 fits into, I mean, that's what I meant, that 3 fits into that. So if your breakdown is at 1, then you gotta, if you're plugging in 3, you gotta look for the line that says x is bigger than 1, because 3 is bigger than 1, right? Yeah, so you have to choose the right row of the thing. All right, did everybody get the answers up here? These are the answers. I checked them with Fred, so I know they're right. We okay? All right, 1-3 is due on Wednesday. We're gonna review again on Wednesday, and we'll probably, well, we'll review again tomorrow, right? Tomorrow, and then again on Wednesday, maybe, let's see how tomorrow goes. We might quiz on Wednesday, we might review for another day, we'll see how it goes.